RoboForth is based on the computer language Forth. The most important and significant feature of Forth and RoboForth is the ability to type a word and see it executed immediately. For example, if I type ready, the robot will go to ready, and if I type home, the robot goes home, and of course dozens, in fact hundreds of other commands. The other idiosyncrasy with Forth, if you like to call it that, is that all values or arguments are passed on a stack. So a function will pick up a value from a stack, and if it has an answer, it will leave the answer on the stack. So for example, if I type 2, that goes onto the stack, and then 3, that goes on the stack with 2 underneath it. This shows the stack. You can see the 3 with the 2 underneath it. Now if I want to add those two together, I might want to write the word add, but that is not a fourth word. The fourth word for add is the plus sign. Now the plus sign is a word. You can make a fourth word out of any characters, and it can be of any length. So plus is a word, and it takes two values off the stack, adds them together, and leaves the answer on the stack. Now if we want to print that value that's on the stack, we might want to use the word print, but print is not a fourth word. It has a short form, which is just a dot. So you press the dot and you get the answer. So the whole line would look like this. 2, 3 plus print is 5. In a syntactic language, we might expect to see something like this. But the syntactic language can't actually handle that. It has to pass along that line. First of all, it sees the word print. It doesn't know what to print. It just knows it has to print something. So it stacks that command for later. Then it sees the number 2, and it knows it has to print 2, but it hasn't got to the end of the line yet. It knows there's more to come. Now it sees the word plus. Now it knows it needs to do an addition, but it's only got one number to add. So it needs to keep passing along the line, and it sees the next number. And at this point, it reaches the end of the line, and it can now do the whole thing. First of all, it has to remember what it was supposed to do with the plus, that is to take the two values and add them together. And then it remembers what it was supposed to do to begin with, which is print something. And the same applies to RoboForth commands or robot commands. The value must come first. So if I want to move the shoulder, for example, as you can see in the picture up there, if I type tell shoulder 2000 move, then the shoulder will move by 2000 steps. Forth has two engines in it called the inner and outer interpreter. The outer interpreter is the one that passes your sentence, that passes what you have typed on the command line. Each word that you type is looked up in the dictionary, and each word has a code field, and the word is passed to the inner interpreter. The inner interpreter looks at the code field and executes that, and that's what results in the final action in a word like move, for example. So when you type move, it's looked up in the dictionary, it's passed over down to the inner interpreter. The inner interpreter looks at the code field and executes that, which in turn may be a whole lot of other code fields for other words that have been used to define the word move. New words are added to the dictionary with a defining word. For example, the word variable is a defining word. I can write which defines v1 as a variable, and v1 is added to the dictionary. but the most important defining word is the colon. Suppose I want to define a word task. I might be tempted to write define task as follows, but that's back to front with forth. Forth has to start with the colon in this way. So we type with a colon, then task, and then we can follow with what task actually does. And in this example I will make it do ready and then home, and then a semicolon finishes that task definition. Now if I write task, the robot will do both of those things. A note about variables. There are some important shortcut words that work with variables. For example, if I have a variable apples, I might write 5 apples store, and the exclamation mark means store that value in that variable. The opposite of store is fetch. So if I write apples fetch, and that's an @ sign, the @ sign means fetch, print the value, and it's 5. And I give a little shortcut as well, which is a question mark. That's quite useful for quickly seeing what's in important variables like speed, for example. Teaching the robot coordinates is something every robot manufacturer has to provide. In these examples, the ABB robot is programmed by entering coordinates. You can see that there are also sliders up on the top left with the actual value of the joint written inside the slider, and that's very neat and very impressive. The middle one is a Toshiba, and that has the coordinates all down on the right hand side. Again, you can change the coordinates. In both those cases there is a picture of the robot as well, so that when you change the coordinates the robot picture changes as well, which is very impressive, but not actually, in my view, very useful, because it's much better to work with the actual robot. And then the third picture is of the Epson robot, and they have kept to just text entry of coordinates and programming, and you can see words like go, point 1, go, point 2, and so on. All these softwares are impressive and slick graphical interfaces designed by engineers for what they think their users will need. But they are essentially applications, whereas RoboForth is built on a real computer language, Forth, which makes it capable of much more complex mathematics and logic if required. And the objective of RoboForth all through is to put the user in contact with the machine. It so happens that Forth has a unique feature. You can define a defining word. You can define a word which is itself a defining word that can define other words. Such a defining word can specify what happens when you define a new word with it, and what happens when the defined word is finally used. So I was able to define a defining word, place. Now I will just move the robot to some position. Let's say move on the x-axis somewhat. And I will write place P1. Of course it can be any name, but I'm just calling it P1. Now, if I go home, and then I write P1, it comes right back to that same position. I can see the coordinates. You can, of course, or you should, create places using RobWin7, but RobWin7 is not an active GUI like in the previous examples. It's simply an aid. It's just an assistant to RoboForth. So you can create them and you can see the positions in it, but the work is being done by RoboForth itself. And so therefore a place is both self-learning and self-executing. Using RobWin, I could of course add a new place using its GUI. I click Add New, I'd call that P1, click OK to that, and as you can see it just sent the same string, place P1, down to RoboForth, and I can see the data for it here. It's a similar position for a route, which is a list of positions. You simply type route and then the name of the route you require. Through RobWin, you use this GUI. We'll call this route R1 in Cartesian mode, and there we are, ready to learn positions. As mentioned before, at the start of each word is a code field. The interpreter sends this code field to a routine called execute. I can find the code field with the word find. So if I find the code field of ready and print it, that number is the code field value. Of course I can do find ready execute, which executes the value instead, which is exactly the same as if I had typed ready. But I can put that value into a variable. Find ready v1 store. This is the variable I created earlier. Now I go back to home. Now I can type v1 fetch execute, and the robot will go back to ready. Why would I want to do that? The reason is that that code field can be put into different variables for all sorts of different purposes. For example, what happens when you press the stop button? A variable called stopvec contains the code field of a word called stop abort, which does that. But you can change that. You might want instead to have the option of continuing and not having an abort. So there is an example of how that might be done. I've defined a new word called eStop. It prints on the screen, press enter to continue or escape to abort. The next line, ask, drop. Ask is a word that gets a value from the user. Since we're not interested in the value, we just drop it. Otherwise it would stay on the stack and be a nuisance. The next word is resume, which basically restores the target coordinates so that the robot can actually continue to the intended destination. Now to get that to happen, instead of the regular stop abort, I would need to type find eStop stopvec store, or the simpler set stopvec eStop, and then from this point on, whenever the robot stops, you get the contents of stopvec. Which is this. Okay, I'll press escape to abort at the moment. It so happens that when you type words into an outer interpreter, the outer interpreter is itself a word, and this word can also be put into stopvec, so that when you press the stop button, what you get is a brand new command line, and you can then investigate, try gripper and that sort of thing. And to do that you simply need to do set stopvec outer. From this point on, it's the outer interpreter that will kick in whenever you press the stop button, and then you just press exit to get out of it. RoboForth uses vectored execution in lots of other ways as well, but before I move on, I'll just mention that all the variables and data and programming are all done in static RAM. Then if you type usave, the contents of the static RAM are saved to flash. Then when you next switch the controller on, the contents of flash are loaded back into static RAM. There are 3 possible entry points set by a key on the front panel. The first one is called cold start. All that does is start up forth. The second position is called warm start. What this does is it re-enters the system in exactly the same place as where you left it, restoring all the context pointers and so on, just as they were when you switched off, or when you typed usave, I should say. And the third entry point is for turnkey mode. In other words, as soon as you switch the controller on, the robot will immediately start moving and doing something. Supposing you have a word here, let's say call it task, that you want to execute as soon as the power comes on. The first thing you'll want to do is start, then you'll want to do calibrate, and then you'll want to do something else. It might be, let's just put something simple in. And then you type, you can do find task turnkey store, or an easier way is provided is just to type auto task, and then you switch the front panel to the auto mode, and then when the power comes back on, the system looks in this location called turnkey, finds the code field from that and starts from there, and will do all of the rest of the word that you've put there. The same variable is also used in a function called restart. Forth is a structured language. There is no go-to. So imagine if you are partway through a cycle of some repeating cycle, and you press the stop button, and what you actually want to do, or there's some other error, and what you actually want to do is start from the beginning. There's no go-to. You can't just go to the beginning again. So what you do is you take the code field address of the beginning of the task, put that in turnkey, and then you use the word restart. What restart does is takes the temporary value that you've put in turnkey and executes from there. Because the power hasn't gone off, you don't need to do start and calibrate. You can carry right on from the beginning of the word that you had the problem with. Another way RoboForth uses vectored execution is for interrupts. You can set up a regular event interrupt, which is an input into the controller, or you can set up a timer interrupt so that something happens at regular timed intervals. You set the time and get things ready. Supposing you have a word, so let's say temp control, as I'm showing here, then it does something, we don't know what, it does something, and then the last word in that definition has to be return. And then you set intvec temp control. So the code field of temp control is put in intvec. Now when the interrupt happens, the machine code for the processor follows a route, takes the code field out of intvec and sends it to execute, and then everything happens from there on. The last word in temp control has to be return, which goes back into the machine code, which then cleans things up and returns everything back to the top level forth.